Our story begins not on Earth, but billions of years ago in the swirling chaos of the early universe. Scientists believe that our solar system was born from a massive cloud of gas and dust called a solar nebula. Gravity pulled this material together, forming our sun at the center and a disk of matter around it. Over time, this matter clumped together, creating the planets we know today. Earth, the third rock from the sun, formed in this incredibly violent and spectacular process, a product of cosmic dust and destiny. We live on a planet that seems huge to us, but it's just a tiny, magnificent speck in the universe. Today we are taking a deep dive into our home, planet Earth. To truly understand its remarkable story, our journey began in the cosmos, placing Earth in its proper context. We are part of solar system, a family of 8 planets, and we are the third one from the sun. Our solar system also includes countless moons, asteroids, and comets, all bound together by the sun's immense gravity. Bias, a unique, privileged spot in our celestial neighborhood, a region scientists call the Goldilocks zone. This is a precise distance from the sun where temperatures are perfect for a liquid water to exist on the surface. But it's not just about temperature, it's also count about atmospheric pressure, which on Earth is just right to keep water from boiling away or freezing solid. This rare combination of perfect temperature and pressure make our planet a true heaven for life. And our amazing atmosphere is protected by an invisible force field, the magnetosphere, generated by our churning liquid iron outer core. This shield deflects the dangerous solar wind, a stream of charged particles that would otherwise strip away our atmosphere, leaving the planet burned and lifeless like Mars. Earth's distance from the sun is 150 million kilometers, which is very far distance, and diameter of Earth is 12,756 kilometers. So it's important to note that Earth is not a perfect sphere due to its rotation. And about the rotation speed, the Earth spins on its axis at speed about 1600 kilometers per hour, which is very fast. Earth orbits the sun at an average speed of about 1,07,088.26 kilometers per hour. So our planet Earth have its natural satellite called Moon. So its distance is from Earth is 3,84,400 kilometers. Our Moon is a constant companion and a vital force. It's theorized that it is formed from a gigantic impact with a proto-planet named Theia. Early in the Earth's history, this cosmic crash created a debris ring that eventually coalesced into our Moon. Its gravitational pull is the primary driver of ocean tides, creating a gentle rhythm for a marine ecosystem. More critically, the Moon's gravitational presence acts like a stabilizer, keep Earth's rotational axis at a consistent tilt of about 23.5 degrees. Without this stability, our planet's tilt would wobble dramatically, leading to catastrophic shift in seasons and climate. So, do you know Earth orbits the Sun at an average speed of about 1,07,826 km per hour? The daily cycle of day and night is also a fundamental rhythm of our planet. The Earth spins on its axis once every 24 hours, a process we call rotation. This is what gives us the rising and setting sun and the consistent cycle of light and dark. Our orbit around the sun, which take approximately 365.25 days, defines our year and give us our seasons. As Earth orbits, its tilted axis means that different parts of the planets receive varying amount of sunlight throughout the year. The northern hemisphere tilts toward the sun in summer, while the southern hemisphere tilts away. This astronomical balance provides the rhythm and stability for all life on Earth. The Earth we stand on is merely the thin outer shell of a complex, powerful engine. Our planet is layered like an onion. The thin, rocky crust we live on is the outermost layer. Below it lies the mantle, a vast, solid but pliable layer of rock that make up about 84% of Earth's total volume. The heat from the core creates powerful convection currents in the mantle, like boiling water in a pot, which slowly move the solid mantle rock. At the very center is the core, a sphere of incredibly hot iron and nickel. The inner core is solid due to immense pressure, while the outer core is a liquid ocean of swirling mantle. This liquid outer core's motion generates our planet's vital magnetic field. Swirling mantle currents are the engine behind plate tectonics. The Earth's crust is not a single piece, but a jigsaw puzzle of enormous plates. At convergent boundaries, plates collide. When two continental plates meet, the land buckles and folds, forming massive mountain ranges like the Himalayas. When an oceanic plate crashes into a continental one, the denser oceanic plate sinks or subducts, create deep ocean trenches and triggering intense volcanic activity. The Pacific Ring of Fire, a horseshoe-shaped belt of volcanoes and earthquake zones, is a prime example of this. At divergent boundaries, plates pull out apart, allowing magma to rise and form new crust, creating vast underwater mountain chain called mid-ocean ridges. And at transformed boundaries, plates slide past each other, building up stress that is released as devastating earthquakes. such as those along California San Andreas fault layers boundaries. Some volcanoes are formed by a different process entirely deep within the mantle. There are isolated columns of hot rocks called hotspots. These hotspots burn through the crust, creating a volcano on the surface. As the tectonic plate moves over the stationary hotspot, it creates a chain of volcanoes. The Hawaiian Islands are a perfect example of this. The oldest islands are far from the hot spot, while the youngest, still volcanically active islands are directly above it. Whether a volcano is formed by a hot spot or a plate boundaries, the eruption of molten rock or lava is a powerful reminder of the incredible forces at work within our planet. Earth is bathed in a vast sea of air, our atmosphere. This life-sustaining blanket is made mostly of nitrogen, about 78%, and oxygen, about 21%. But it's not a single layer. The lowest layer is the troposphere, where we live and where all weather happens. About that is the stratosphere, which contains the ozone layer. This thin shield of ozone gas is absolutely critical as it absorbs the sun's harmful ultraviolet UV radiation, protecting all life on the surface from its damaging effect. Higher still are the mesosphere, thermosphere, and exosphere, each with unique properties that protect our planet from meteors and space radiation. The atmosphere also regulates our planet's temperature through the greenhouse effect. Sunlight enters, warms the surface, and some of that heat is radiated back. Gases like carbon dioxide and methane trap some of this escaping heat, keeping the earth at a comfortable temperature. This is a natural, necessary process. However, the burning of fossil fuel has significantly increased the concentration of these gases, making the atmospheric blanket too thin. This has led to global warming, which has caused rapid climate change. Consequences include more external weather events, rising sea levels, and ocean acidification, which harming marine life. The atmosphere is also the engine of water cycle. Water evaporates from oceans, lakes, and even from the plants through a process called transpiration. This water vapor rises, cools, and condenses into clouds. These clouds move with wind, eventually release their moisture as precipitation, rain, snow, or hail. The water then collects in river and lakes or seeps into the ground. This constant global process ensures a supply of fresh water and is responsible for all of our weather pattern, from gentle breeze to powerful hurricanes. Nowadays, some countries using artificial rain or cloud seeding is a weather modification technique that introduces substances like silver iodide into cloud to stimulate rainfall. Its bad effects include potential long-term buildup of chemicals in the environment, disruption of natural weather pattern, health risk from prolonged chemical exposure, and the possibility of worsening local air pollution or shifting rainfall to other areas. It's also not a foolproof solution. It's is costly, requires suitable weather condition, and can be distraction from addressing the root cause of problem like drought or pollution. Earth is not just a planet of rock and air. It's a planet of life in staggering a variety. The planet's surface is home to different biomass, large communities of plants and animals adapted to their specific environment. The tropical rainforests are the most biodiverse with layered canopies and an incredible density of species. In contrast, the deserts, both hot and cold, have very little rainfall but are home to highly specialized plants like cacti and animals like camels that have evolved incredible ways to conserve water. The tundra is a frozen landscape where life survives in a perpetual deep freeze. About Wyoming is a large geographical region characterized by a distinct climate and specific type of plants, flora and animals, fauna that have adapted to those conditions. These distinct communities of living organisms are shaped by abiotic factors like temperature, rainfall, soil and water availability. Examples of major biomes include tropical rainforest, desert, grasslands, temperate deciduous forest, taiga, tundra, and various freshwater and marine biomes. The largest biome on Earth is the ocean. It's so vast that it's divided into zones. The sunlit zone and the top is where photosynthesis occurs, supporting most of marine life below this. The twilight zone where only faint light penetrates and life adapts with large eyes or bioluminescence. Then there is the midnight zone, a realm of complete darkness where bizarre creatures thrive on dead organic matter falling from above, and where some ecosystem exists around hydrothermal vents powered by chemical rather than sunlight. This unique environment proves that life can find a way to survive in the most extreme condition, and we should study about it. This amazing variety of life or biodiversity is the foundation of our planet's health. Every species from tiniest to microbe in the soil to the largest whale in the sea play a role. The loss of a single keystone species like the sea otter can lead to collapse of entire ecosystem. Can you imagine this? The sea otter eats sea urchins, which in turn eat kelp forests without the otters. The urchin population explode and the kelp forest, a critical habitat from thousands of species, disappear. Every living thing is the part of interconnected web, so we should respect each other. The story of Earth is one of incredible resilience and beauty, but today its health is at breaking point. The challenges are daunting. Climate change threatens our very existence. Plastic pollution chokes our ocean and contaminates our food, and deforestation destroy critical habitats and accelerate global warming. These problems are not natural. They are human-made, but here the powerful truth. If we created these problems, we also have the power to solve them. So we should focus on this and help each other to grow a healthy earth. We know that above the water and lands is our atmosphere, a gaseous ocean divided into five main layers. The troposphere is the lowest layer, and stratosphere, mesosphere, thermosphere, and exosphere. Each layer have a specific job working together to make Earth habitable world. Weather is the product of these atmospheric forces. The sun heats the earth unevenly, creating differences in air. Air moves from high pressure area to low pressure area, creating wind. When warm, moist air rises, it cools and condenses, forming clouds. This can lead to rain, snow, or even powerful storm. Global wind patterns are influenced by the Coriolis effect, creating predictable large-scale system. The El Nino Southern Oscillation, for example, is the periodic warming of the Pacific Ocean that has major impact on weather pattern across the globe. We must also talk about the cryosphere, the frozen part of our planet. This includes glaciers, ice caps, and sea ice. The massive ice sheets in Greenland and Antarctica hold a staggering 99% of the world's freshwater. These frozen reservoirs are vital climate regulators, reflecting sunlight and cooling the planet. Scientists study ice core to look back in the time, analyzing ancient air bubbles trapped in the ice to understand past climate and the history of our atmosphere. The greatest story on Earth is the story of life itself. The first life forms appeared about 3.7 billion years ago, likely as single-celled organisms in the ocean. The early atmosphere had no free oxygen, but a evolution occurred within the evolution of cyanobacteria. These organisms began to photosynthesize, producing oxygen as waste product. This great oxygenation event changed the atmosphere forever, paving the way for more complex oxygen-breathing life to evolve. The Cambrian explosion about 540 million years ago saw a rapid burst of life and the emergence of most major animal groups. Life on Earth is organized into a web of ecosystem within large biomass. We have terrestrial biomass on land and aquatic biomass in water. The tropical rainforest, the Earth's lungs, producing oxygen and housing over half of the world's species. The savannas and grassland are the vast plains that support massive herds of grazing animals. The tundra and boreal forests are the cold adapted biomass of the polar and subpolar regions, and in the water, coral reefs are rainforests of sea, teeming with vibrant life, while wetlands and estuaries are critical nurseries for countless marine species. The incredible variety of life is called biodiversity, and it is the key to healthy planet. A diverse ecosystem is a resilient one. Each species, no matter how small, has role to play. Think of a keystone species like wolves in Yellowstone National Park. The reintroduction of wolves changed the entire ecosystem, allowing beavers and other animals to return and restoring the health of entire landscape. The loss of single species can have cascading effect, disruption the entire web life. In recent event, they bring dire wolves back in Earth. They was the extinct species. I'm not sure about it should be done or not. For millions of years, human evolution was part of the natural story, but over the last 10,000 years, within the rise of agriculture and more recently the industrial revolution, our impact has become so profound that scientists now refer to our current period as the Anthropocene, a new geological epoch defined by human activity. We are no longer just a part of the ecosystem, we are the dominant force shaping it and also destroying it. And our choices are having global impact on the every system we have discussed today. The earth is sending us clear message. The symptoms of our impact are everywhere. You can see everywhere pollution and everything. Climate change is accelerating, causing more frequent and intense storm, droughts, and heat waves. Plastic pollution has become a global crisis within microplastic, now found in every corner of the planet. From the highest mountain to deepest ocean and even in our bodies, deforestation is destroying habitats at an alarming rate, pushing countless species toward extinction, and we are seeing alarming rate of ocean acidification caused by the ocean absorbing excess CO2, which threaten very foundation of marine food chain. But if new story is also being written, one of hope and innovation. The transition to clean renewable energy is underway, with solar, wind and geothermal power become more affordable and accessible than ever before. Sustainable agriculture like regenerative farming is helping to restore soil health and combat climate change. The circular economy, which aims to eliminate waste and keep resources in use, is gaining momentum. We are seeing incredible conservation effort to protect endangered species and restore damaged ecosystems. Fight to protect our planet require action on every level. It starts with individuals making conscious choices about their consumption and waste. It continues at community level through local initiative and sustainable urban planning, and it must be culminate in global collaboration and political will. International agreements like the Paris Agreement, though imperfect, are step toward a shared goal. Investing in scientific research and education is also vital. We cannot solve problems we do not understand. The journey of our planet is long and complex, one from cosmic dust to living birth world. It is the only home we have, and it is a masterpiece of balance and interconnected system. The story is not over. We are not critical crossroad, but we are also armed with knowledge, innovation, and collective responsibility. The future of Earth is in our hand. Let's make it bright, healthy, and sustainable and good. We have explored the incredible complexity and beauty of our home. We have seen how it functions from deep core to vast reaches of space. We have seen its power and its fragility. This planet is a miracle and we are its guardian. Let's make a promise to be good stewards of Earth. Thank you for joining us on this journey. For more content like this, be sure like this video and subscribe to our channel. The future of our home is in our hand. Let's make it bright one. Now I am going to start next part of this video about the Earth future. So hope you enjoyed this video. So now this is the end of the video, and I'm going to say goodbye. See you.